All right, so this section is going to be on angles of rotation with our geometry, or not geometry, but our trigonometry functions. And so with this, in geometry, an angle was defined as two rays that share a common endpoint. So for example, you may have an angle right here. There's two rays and the common endpoint right here, which is called your vertex of the angle. Now in trigonometry, an angle is going to be described as a ray that rotates about the vertex. And the vertex is going to be at the origin in particular. The beginning ray is going to be called the initial side of the angle, and it's going to be rotated about its endpoint. And then the final position is called the terminal side of the angle. So we have initial side and we have terminal side. Now, an angle can be formed either by rotating your terminal side clockwise. So for example, you could rotate this way, clockwise. Clockwise would be this way. So you can rotate an angle clockwise going this way all the way around your circle or coordinate axes. You can also rotate an angle counterclockwise going this way. And angles are often going to be named using Greek letters: alpha, beta, gamma, and theta, theta being the most commonly used name for an angle. Now, an angle in standard position. An angle is called an angle in standard position when it is positioned on a rectangular coordinate system with its vertex at the origin and its initial side on the positive x-axis. So this side right here is going to be called your initial side, and then the side that rotated around is going to be your terminal side. Okay. And the angle is in standard position because it is rotated around the origin, and you have one side, your initial side, on the positive x-axis. All right, so angles are often measured in degrees, and that's what you're probably most familiar with from geometry. One complete counterclockwise rotation is defined to be 360 degrees. Angles can make more than one revolution and therefore can have measures greater than 360 degrees. And so when rotating clockwise, counterclockwise, your measure is going to be a positive angle measurement. When you are rotating clockwise, the angle measurement is going to come out to be negative. So for example, on this angle here, it has been rotated counterclockwise, and so therefore this is a positive 130 degrees. This angle was rotated clockwise, and therefore its angle measurement is negative 115 degrees. So anytime you rotate by going up, which is counterclockwise, that is going to be a positive angle measurement. Anytime you rotate going down, which is clockwise, that's going to be a negative angle measurement. Next definition is for coterminal angles. And two angles are coterminal if they have the same initial side and the same terminal side. And then coterminal angles can be found by adding or subtracting an integer multiple of 360 degrees. So if we look at this question here, it says find a positive and a negative coterminal angle for a 60-degree angle. So let's start with this one right now. So a 60-degree angle would be approximately right here. Now, for this 60-degree angle, we rotate it up. And let me go ahead and write the 60 degrees in here. We started on this side, we ended on this side. This is your initial side, and this is your terminal side. Now, this angle was drawn at 60 degrees, but that's not the only angle that is involved here. If we had rotated this direction right here, that would be starting at the same place and ending at the same place. And yet that angle is negative 300 degrees. So if you rotate this way, let me do this in a different color. If you rotate this way, that would be negative 300 degrees. Those are coterminal angles. The 60 degrees and the negative 300 are coterminal because they have the same initial side and the same terminal side. Now, another way to get a coterminal angle would be by starting here and rotating all the way around and then coming back to here. That would be 420 degrees because we went the 60 degrees, but then we went a whole nother circle, which would be another 360 degrees. And so that gives us a total of 420 degrees. Now, what that means is that we got our coterminal angles two different ways. You can take that original 60 degrees and add 360 to it. That gave us this angle. We could also take that original 60 degrees and subtract 360 from that. And that gave us the other coterminal angle. One of them was positive and the other one was negative. All right, so now let's look at the next problem here. So negative 210 means that we are rotating from here going down. That would be our negative direction. Now from here to here is negative 180. So we need to go another 30 degrees this way. So that would put us about right here with negative 210 degrees. All right, so we could get a coterminal angle by rotating this way instead, and that would be the same initial side and the same terminal side. And so we would get this measurement by taking our negative 210 degrees and adding 360 to that. And that would give us 150 degrees. So this angle is a positive coterminal angle to that negative 210. Now we could also have started here, rotated to here, but then go another whole circle around. Well, that would be another 360 degrees. So that means we could take our original negative 210 and subtract another 360 degrees from that, which would give us negative 570 degrees. That would be a negative coterminal angle to the original. All right, so this problem says to sketch a graph of the following angles in standard position and find one positive and one negative coterminal angle. All right, so if we start with our 30-degree angle, 30 degrees, here's our initial side, and then our terminal side would be about right here. So that is 30 degrees. So if you take your 30 degrees, adding 360 to that would give you 390 degrees for a coterminal angle. And if you subtract 360, that would give you negative 330 degrees for a negative coterminal angle. All right, the next one is 145 degrees. So 145 degrees would be somewhere over here, going this way. And so if you take that 145, add 360 to it, that's going to give you 505 degrees. And if you take the 145 and subtract 360 from that, let's see, that'll give you negative 215 degrees, and that would be another coterminal angle. All right, and so then the last one here is going to be negative 400 degrees. Negative tells us to rotate this way. Now, if you rotate all the way around one time, that would be negative 360 degrees. So we just need to go another 40 degrees past that. All right, so that would put us approximately right here. So the angle would start here and go around this way. More than one complete revolution. Now, if you take negative 400 degrees and add 360 to that, that is going to give you a negative 40 degrees. That is still a negative coterminal angle. If we want a positive coterminal angle, we would need to add 360 another time. And so if you take your 40 degrees and add, or negative 40 degrees and add 360 to that, that will give us 320 degrees for a positive coterminal angle. All right, a couple of definitions from geometry that should be familiar. Supplementary angles are two angles whose measures add up to 180 degrees. And then complementary angles are two angles whose measures add up to 90 degrees. So this says find the complement and supplement to a 48-degree angle. The complement you're going to get by subtracting that 48 degrees from 90. And so the complement would be a 42-degree angle. And then the supplement, you would subtract the 48 from 180, which would give you a 132-degree angle. All right, so in addition to the degree, there is a second unit of angle measurement called the radian. Radian measure is a unit of angle measure used frequently in trigonometry, calculus, and more advanced mathematics. And in all honesty, most of the time you will be using radians from here on out, especially in pre-cal and calculus. You'll be using radians almost all the time. And so the definition, what is a radian? 1 radian is the measure of a central angle, theta, whose intercepted arc has a length equal to the circle's radius. All right, so let's translate what that means. If you have a circle right here, and we want to figure out, well, how much is this angle going to be? Well, let's think about degrees for a second. If you have a circle, 1 degree would be very small measurement. I can't even draw a 1 degree angle small enough actually to be able to show up in here accurately. So 1 degree is very small. What that means is that 360 of these would be what it would take to fill up this circle. And just to go from here vertical, you'd have to have 90 of those to fill up this region right here. So 1 degree is very small. A radian is not that small. So how big is 1 radian? Well, if you draw the radius of a circle, and let's say you put a piece of string on this and measured it to be 5 inches. Now, if you lay that piece of string along the curve of the circle and measured out that same 5 inches, wherever that stops, if you draw another radius to that point, the angle created right here would have a measure of 1 radian. Now, a radian is an angle measurement, but it is also a length of an arc. So a radian is a length as well as an angle measurement. Okay. So a circle with radius 1 is called the unit circle. The unit circle is something we will be using frequently, not in just this class, but in pre-cal and calculus, you will be using that unit circle all the time. The radian measure of a central angle of a unit circle is equal to the length of the intercepted arc. So if you remember your properties from geometry, when you have a circle and you have a central angle, which means the vertex of your angle is at the center of the circle, the measure of this angle is equal to the measure of this arc. Now, it's not equal to the length of the arc, it's equal to the measure of the arc, which means if this angle is 20 degrees, this arc would be 20 degrees as well. Now, for radians, the measure of the angle is equal to the length of the arc as well. So 1 radian is the angle, it's also the length of the arc. On a unit circle, the circumference, which is 1 revolution, is 2 pi. So all the way around a circle is 360 degrees. It's also equal to 2 pi radians. This means that half of a revolution, or 180 degrees, would be equal to pi radians. Now, degrees have a little symbol that you put on it. If you don't put a symbol, then that means you are automatically talking about radians. It is understood to be radians if you do not put a symbol. We don't normally write the word radians after the measurement. Right. So the conversion, what is the conversion between radians and degrees? All right, so let's think about this for a second. If pi radians is equal to 180 degrees, then what would 1 radian equal? Well, to do that, what you would do is divide both sides by pi, because pi divided by pi would give us 1. Therefore, 1 radian is equal to 180 divided by pi degrees. So now, if 180 degrees equals pi radians, then 1 degree, how would we get that? Well, you would divide both sides by 180, because 180 divided by 180 would give us 1 degree. All right, so therefore, 1 degree is equal to pi divided by 180 degrees. Radians, rather. Okay. All right, so now let's think about what we've got here. If 1 radian is equal to this many degrees, then this many radians, how do we get how many degrees it would be? Well, if 1 is equal to this, then we would have to multiply this value by 180 over pi. All right, so we're going to multiply by 180 over pi. Your pi's will cancel. The 2 and the 180 will reduce, and 3 times 90 is 270 degrees. All right, so the next one, 2 pi over 3 radians, if you multiply that by 180 over pi, once again your pi's will cancel. 3 and 180 reduces, and then 2 times 60 is 120 degrees. And then the last one here, when you multiply by 180 over pi, once again the pi's cancel, and then the 4 goes into 180, 45 times, and then 5 times 45 is 225 degrees. All right, so then the other conversion is degrees to radians. So if 1 degree equals pi over 180, then 30 degrees you would have to multiply by pi over 180. 30 and 180 reduces to give you pi over 6 radians. Next one, if you multiply by pi over 180, will give you pi over 4 radians. And then 90 degrees multiplied by this will give you pi over 2 radians. And then our last definition here is going to be of a reference angle. And a reference angle is the acute angle, acute meaning less than 90 degrees. So it's the acute angle formed with the x-axis, and it is always formed with the x-axis. And the reference angle will always be a positive angle measurement. All right, so here it says find the reference angle for each of the following. So for a 345 degree angle, if you think about the graph of this, 345 degrees would be here for your initial side, and then rotating around almost 360 degrees. So 345 is to here. Well, the reference angle is the acute angle formed with the x-axis. That's this angle right here. And this angle right here, if the whole thing out here was 345, what's left over is going to be 15 degrees, because 345 plus the 15 would put us back at 360 degrees. All right, so let's look at the next one here. All right, so 5 pi over 12. 5 pi over 12. 5/12 is a little bit less than a half. And pi over 2 is right here. So that means 5 pi over 12 is going to be about like this right here. Now, if you'll notice, since this is less than 90 degrees, this is already the reference angle. So 5 pi over 12 is its own reference angle. Now, pretty much anytime you are given a measurement in degrees, you're going to answer in degrees. If you are given a measurement in radians, you are going to answer in radians. All right, so then the next one, it's going to be negative 9 pi over 7. So negative tells us to rotate this way. Now, if we rotate to here, this is 1 pi, which would be 7/7. So 9/7 is going to be a little bit more than that. So negative 9/7 will be in this quadrant right here. Now from here to here is 9/7. The acute angle with the x-axis is this one right here. All right, so from here to here would be 7/7, which means this part right here is going to be 2/7. And so your reference angle is going to be 2 pi over 7. And as we mentioned, even though that was a negative angle, it says up here that the reference angle will always have a positive measure.